Georges Creek River Valley sits in western Maryland in Allegany County. Georges Creek flows down to Westernport, Maryland, where it meets up with the North Branch of the Potomac River. Georges Creek is fed by numerous tributaries along its river valley. Shortly after 5 p.m. on May 12, 2025, intermittent rainfall began across western Maryland, transitioning to steady rainfall after 2 a.m. on May 13th. By around 8 a.m. on May 13th, rainfall rates began to increase along the eastern-facing slopes of the mountains of western Maryland and eastern West Virginia, with peak rainfall rates reaching over a half-inch per hour by early afternoon. Flooding began around 12:30 p.m., and by around 1 p.m., life-threatening flash flooding was occurring across western Maryland. Locations along Georges Creek suffered catastrophic damage. In particular, Westernport Elementary School saw water breach up to its second floor, trapping students and staff. At around 1:30 p.m., an evacuation began of Westernport Elementary School, and by 2 p.m., Allegheny County Public Schools dismissed schools in the county. At 2:49 p.m., the National Weather Service issued a rare flash flood emergency for Westernport, Luke, and Barton, Maryland. By the end of the day, rainfall amounts of 2 to 4 inches fell across western Maryland, with a localized bullseye of greater than 5 inches just northeast of the Georges Creek River Valley. This is the May 13th, 2025 Western Maryland flood disaster. In this analysis, I'm going to focus mainly on the Georges Creek River Valley, even though flooding was quite widespread. I'm going to cover what made this weather event special, whether there was advance notice, how accurate was the forecast, and how was the flooding threat communicated. I'm going to cover how we can better prepare for the future, how we can help, and how and where help is available for those affected. First of all, what made this weather event so special? The summary is that rainfall was produced by an upper level low pressure system with moisture transport from the Atlantic Ocean. This rainfall was enhanced by orographic lifting and a southeasterly low level jet. Before we go any further, it's important to look into the minds of forecasters during the event itself. This is called the Area Forecast Discussion and is issued by your local National Weather Service office. And this forecast discussion was issued the night before the flood event. And these forecast discussions are publicly available, and you can read into the thought process behind a forecast from the National Weather Service. The forecast discussion the night before mentions an upper low, and an upper level low is simply a low pressure system in the upper levels of the atmosphere. There were little to no surface features during the event, only this upper level low, so that's our focus, and how the upper low was beginning to drift northeast toward western Maryland. The forecaster mentioned that steady rain was expected through most of May 13th, with a zone of large-scale ascent. Now, ascent is a fancy word for rising motion. Finally, the forecaster noted a general 2 to 4 inches of rain was expected through late Tuesday night across the flood watch area, with localized higher totals along the eastern-facing slopes of the Blue Ridge and Allegheny Mountains, where upslope southeasterly flow was expected to enhance rainfall totals. So now let's take a look at the analysis maps. This is what's called the 500 millibar map, and it shows geopotential height, which gives us our locations of highs and lows pressure at this height level, and also upper level winds. Now the 500 millibar height is roughly around 3 miles in height above the surface, and this map is valid for 8 a.m. May 13th. And we can see here that we do have an upper level low, and just ahead of our upper level low we have what's called the area of preferred rising motion. And meteorologists look for areas of rising motion because rising motion means you're likely seeing clouds and precipitation. Now, what was also special about this upper level low was that it was negatively tilted, which means the air flow at 500 millibars over western Maryland was actually coming from the south. If we go down to 850 millibars, which is lower in the atmosphere, just about 1 mile in height above the surface, again valid at 8 a.m. on May 13th, we see that the winds are actually coming out of the southeast. And that's very important because we can look at another map called the 850 millibar moisture transport. And we can see with these shadings that's showing where is moisture being transported. And since we have airflow from the southeast, we had moisture being transported directly from the Atlantic Ocean up into the mountains of western Maryland. This was our moisture transport, and that's very important because you need moist air to flow over mountains to get upslope flow, which I'll cover in a little bit. If we go to the map, moisture transport map at 2 p.m., you see the moisture transport actually intensified across western Maryland. Now, upslope is a term you hear a lot about in the mountains, and we typically hear about it during the winter with upslope snow, but the same principle applies to upslope rain. You see, when wind blows against a mountain or a hill, it is forced to rise. This is called orographic lift. Now, as moist air rises and cools, water vapor condenses, and that results in clouds and precipitation. This results in the windward side of the mountains and hills receiving more precipitation than surrounding areas. That's what we mean by the word upslope. Now, a normal upslope flow across western Maryland is like this. Air is typically moving from the west to east, and this means the windward side is not over the Georges Creek River Valley, further to the west. But on May 13th, 2025, we had flow out of the southeast, so air was flowing from southeast to northwest, and that put the windward side, the enhanced precipitation, right over western Maryland, and more specifically, the Georges Creek River Valley. Now, if we look at the area forecast discussion, again from the National Weather Service, during the event, 3:59 p.m. on May 13th, we see that again along the same lines that the forecast was going as planned, saying that rainfall was enhanced along the eastern facing slopes of the Blue Ridge and Allegheny Mountains with an upslope flow with a strong southeasterly low-level jet. Now, a low-level jet is just a fast-moving current of air, and that just means you had more rigorous rising motions, and that allowed for more clouds and precipitation. And the forecaster mentioned that there was flooding occurring, and the hardest hit location was southwestern Allegany County, where the Georges Creek was at its second highest ever recorded level, and that a flash flood emergency was in effect for southwestern Allegany County. So I've already clued you in a little bit, but again, was there advance notice? How accurate was the forecast? And how was the flooding threat communicated? And my summary is that while the flood threat was communicated in advance, and I'd say the forecast was correct, the public did not properly interpret the language of locally higher amounts and scattered instances of flooding. You see, there's an inherent impossibility to predicting exactly where the highest amounts are going to occur and also where the worst flooding is going to occur, and that is very challenging to communicate to the public. You see, the National Weather Service in Baltimore, Washington, which covers western Maryland, they issued a flood watch the day before at 1:25 p.m. Now, for Somerset and Bedford counties, which are in southwest Pennsylvania, just across the Mason-Dixon line, a flood watch was issued during the early morning hours on May 13th. Now, the watch statement for western Maryland read 2 to 4 inches are likely, with locally higher amounts along the eastern slopes, and this may lead to scattered instances of flooding. It is these two statements, locally higher amounts and scattered instances of flooding, that as a meteorologist we understand, hey, there could be a quote-unquote boom scenario where the forecast is where the actual reality is higher than forecasted, and that could lead to worse flooding. But to the public, that was not interpreted, and that is the challenge because there you get to a cried wolf effect or a false alarm where if we forecast higher than forecast if we forecast higher amounts than actually that they occur all the time, the public does not care. Yet there is always the possibility of a boom scenario that leads to a catastrophe with almost any weather event. Now, the difference between a flood watch and a flood warning is that a flood watch means that flooding is possible in the near future, but it's not necessarily occurring. A flood warning means that flooding is happening or is about to happen and that you should take action. The first flood warning in western Maryland was issued at 12:23 p.m. on May 13th. The flood warning stated that the small stream flooding was expected. The first flash flood warning in western Maryland was issued at 12:57 p.m. and a flash flood warning is just a higher severity than a flood warning. And the warning statement said flash flooding was caused by heavy rainfall. At 1:03 p.m. on May 13th, the National Weather Service updated that flash flood warning to include life-threatening flash flooding. And just 27 minutes later was when Westernport Elementary School began the evacuation process. At 2:49 p.m., the National Weather Service issued a rare flash flood emergency for Westernport, Luke, and Barton, Maryland. And the emergency statement read a particularly dangerous situation. and that the water level had surpassed major flood stage, and that numerous buildings and roads in the town of Westernport and points upstream were flooded. So there were three main factors that really led up to this disaster. The number one was the timing. The flooding occurred during the school day, with really no previous precedent to cancel schools based on forecasted flooding. Second of all was the location. The highest rainfall amounts occurred near the vulnerable valleys along Route 36 and Georges Creek. And finally was the forecast communication. And while the flood threat was communicated in advance and the forecast was correct, there is that challenge to, or even a possibility to predict, okay, where is that bullseye going to occur? And sadly, the bullseye occurred right in your most vulnerable area, right there along the Georges Creek River Valley. In fact, the rainfall rates during the early afternoon were so much along those eastern-facing slopes that the rain fell faster and conditions worsened faster than officials, emergency crews, or even the public could react, and by that point, it was too late. Preparation for floods needs to occur well in advance because there's very little that can be done besides active rescues during the flood itself. So again, the question is, how do we prepare? And the summary is that we need to learn and improve our flood readiness. Now, the Allegheny County Public Schools set a good precedent a year later on Wednesday, May 28th, 2026, when they canceled due to forecasted flooding. And while we're always going to need to be careful regarding false alarms, or basically the cried wolf effect, this was an important step in the right direction to protect students and staff. And now that this precedent has been set, it may be important for the school district to set some expectations for the public and meteorologists. Some questions that ran through my mind are, will the Allegheny County Public Schools cancel for every single flood watch? And if not, what is that criteria? Second, is the decision going to be made purely at the local level, or will Allegheny County Public Schools consult the National Weather Service? And thirdly, while this cancellation was waived back on May 20th, 2026, meaning that the last day of school was not affected, how will multiple forecasted flood events affect the students' last day of school? Basically, is there may need to be some sort of guidelines similar to our snow day policy. For the public, again, you need to know that difference between a flood watch and a flood warning. When you get a weather alert on your weather app or it pops up on your phone, you need to be able to recognize it and take action. Second, please consider purchasing a NOAA weather radio. Now, NOAA weather radio provides live official weather alerts regardless of cell service and regardless of whether you have power or not. Thirdly, if you're a business owner or your family, your personal lives, you need to identify your flood risk and develop a plan. Do you work, or do you live near, or do you even commute over a river, creek, or stream? Second, if a flood watch is issued, how are you going to prepare? And thirdly, if a warning is issued, how will you take action? Basically, you need to identify your risk assessment. And while you can't always base yourself on what has happened previously, you can say, okay, well, in my time of living, has this river flooded, or could it flood? Is it prone to flood? And then also add yourself a little buffer and say, well, even though it hasn't did it quite yet, what would happen if it did? Basically, you want to prepare for floods before they happen. We want to be prepared, not scared. And also, during a flood, you should never drive through floodwaters. Turn around, don't drown. Finally, where is help available and how can we help? Well, for information on assistance and donations, please visit these two links. One is from the Allegheny County government, and the second is from the Allegheny Health Department. And these are my sources. And thank you for listening to this weather analysis. And I hope you stay weather aware and stay tuned. Thank you and goodbye.